Welcome to Calbeckistan, the place where anybody can learn math. I'm Mr. Calbeck. Today we're going to start talking about tangent. Tangent is the first function that we're going to be looking about in trigonometry. So if you don't have any clue what any of that means, this is the place to start. If you want to know a little bit about what we're looking at, you've probably seen it on your calculator before. There's some buttons. Sin, cos, tan. And you're like, what the heck is that? Well, tan is short for tangent. So don't say tan in your math class. Tan's what you get at the beach. Tangent is what we do in geometry. So let's jump in and we're going to learn what the heck this is all about. Before we get started about tangent, though, I want to remind you a little bit about special right triangles we learned from last time, because there's going to be some good connections there between that and the tangent. The first is to remember that we can actually find any triangle's side lengths based on this template. We only need to know that the angles are 30, 60, and 90, and we need to know one side length, and we can find out everything else about that triangle. And the reason that we know that is because we know everything about this basic triangle, this basic special right triangle. If you don't know what I'm talking about, go ahead and look at the video I have on special right triangles. There's a link in the description. But what I want to do here is be like, well, how can I use this to find any side length? Let's imagine that this is another 30, 60, 90 triangle. And I know that this side is 6 units long. Now, what you remember from before is that the special right triangles all have a scale factor, and you just have to find that. I know that there's a relationship as well between two side lengths. I know that this side is always going to be double the short side. Okay, I know this is going to be 12. I know this side is going to be whatever the short side is times the square root of 3. Okay, and that's as difficult as it needs to be. You can very quickly and very easily find the side lengths of any of those triangles. They have to be a 30, 60, 90, but once you know that, you can find out whatever you want about them with very little work. The problem is, what happens if it's a little different triangle? What if I've got something like this? I've got a 20, 70, 90 triangle. Now, the special right triangle won't work for this. You don't know anything about this triangle. You haven't memorized anything about it. So I would need to know another similar triangle to 20, 70, 90 triangle to be able to figure this out. I could use a proportion or something else. But there's no other way to find it. I would need to know, and if I changed it even a little bit, if this becomes 21 degrees, this would be 69 degrees. Cue all the middle school boys laughing right now. Then this would be another different triangle even so. The problem is there's literally an infinite number of different triangles I can make, right triangles I can make, just by adjusting the degrees a little bit. And every single one of those infinite number of different triangles has a different side length proportion, a different ratio. And so we can't find out anything about this one. What the tangent function does essentially allows us to find the special right triangles, the special right triangle ratios of literally any triangle, which is really cool. You don't need to memorize the special right triangles of 21, 69, 90. You don't need to memorize the triangles of 10, 80, 90. All of the different triangles you could think of. You just need to understand how the tangent function works, and the tangent function will allow you to convert any triangle and find any number of side lengths, which is really cool. Okay, so let me show you a little bit about what that means. So let's see how we can use the tangent. We gotta learn a little bit more about how the side lengths work, and then I'll show you how the tangent works. First, you're gonna be looking for an angle. Now, usually in math, we use Greek letters to represent angles. So I'm gonna use the letter alpha there. You can think of it as an X. But if you see alpha, another one that's really common is beta. And these are just Greek letters. They stand for variables. Don't be tripped up by them. Okay, so I need a right triangle, first of all. It's got to have a right angle in it. And I'm looking for an angle. So we need to understand how to talk about the different sides. The first side we're going to talk about is the hypotenuse. I told you a really easy way to find the hypotenuse, regardless of the orientation of your triangle, is to find the right angle and draw an arrow from it. So you can draw an arrow from your right angle, it will always point to the hypotenuse. Okay, so this is the hypotenuse. Now, there's also going to be a side length that's next to the angle. Okay, I've got the hypotenuse already, and then there's this other side that's next to whatever your angle is. Okay, we call that the adjacent side. Adjacent is just a word that means next to, so it's a pretty good choice for what we're doing here. Okay, now we have this last side here, and this is the last side that we say is across from the angle. So you can draw an arrow from your angle, and that will point to the angle across from it. We don't use the word across, though. In math, we got to make it confusing. So we're going to call it the opposite side because it's opposite your angle. So we have our three sides, and every triangle has three sides that you could talk about. There's a hypotenuse because we're looking at right angles or right triangles only for right now. There's a side next to the angle, which is the adjacent side, and then you can draw an arrow directly across from your angle, which will point to the opposite. Okay? Now here is how the tangent function works. What it does is it takes an angle, any angle, and we'll just use the variable alpha to represent any angle. So the tangent function is going to take an angle, and what it does is it turns that into a ratio or a fraction of side lengths. It gives you the opposite over the adjacent. Now this looks super weird right now, but it's not that confusing once you see a few examples. So we're going to look at a few examples, and we're going to try to figure this out. But what I want you to remember is that tangent takes an angle and gives you side lengths. Okay? You might even want to write that in your notes. Tangent takes some angle, whatever that is, and turns it into side lengths. Okay? And we use those side lengths to find everything else about the triangle. We can start by looking at what that would do in a special right triangle. So first thing you want to do is look for your angle. It's always going to be one of these two angles. You're not going to put the 90 degree in very often. So I want to put in 45 degrees. Now if we are looking at this and say, okay, so the tangent of an angle is supposed to give me side lengths. I actually know the side lengths already, so we can check this. The tangent of 45, I got to find the opposite, so I'm going to draw my arrow to points to the opposite. So this is the opposite side. So it should give me the fraction 1 over the adjacent side. And the adjacent side is the one that's next to it, that's not the hypotenuse. So the hypotenuse is the square root of 2, because that's across from the right angle. So the other one, the adjacent side, is 1. So if I type this into my calculator, if I type tangent of 45, and you can go ahead and do that right now. So again, you hit your tangent button, and then type 45. Okay, and if you've got another kind of calculator, it's going to be the same idea. And you're going to hit enter. And if you hit enter, it should give you 1. And mine does as well. If it doesn't give you 1, I'll show you real quickly what to do there. You have an issue in your calculator, you need to just modify it real quickly. So I want you to find the mode button right at the top here. And once you do the mode button, I want you to scroll down until you see something that says radian or degree. You need to make sure that degree is highlighted. All you need to do to highlight it is move your cursor over to it and hit enter. And it will be highlighted. All that means is you're using radians or degrees. Radians are kind of like this Celsius of angle measures. They make more sense, but you're not used to them, so stick with degrees for right now. So there we go. We have the first tangent that we can use. Now let me show you how you can actually use this in order to find lots of other angle measures, okay? Because again, this works for any triangle, not just a special right. So we're going to take a look at using tangent on my 20, 70, 90 triangle from before. First thing we need to do is find an angle. Again, it's any angle you want that's not the 90 degrees. I'm going to use the 20 for right now. And again, all you're doing is you're putting 20 in this tangent function. Remember, tangent takes an angle and it gives you side lengths. which means it's going to give me these two side lengths. So what I want to do here is I want to find the opposite, which is going to be x this time. I don't know the opposite side. So I'm going to put an x there in my fraction. And then the adjacent side, remember, is the one that's next to the angle that's not the hypotenuse. So 20 over 10, this 10 is the one that's next to it. The hypotenuse is this longer side across from the 90 degrees. So I'm going to put 10 in here. Now, right now this doesn't look like a lot of help. But remember, tangent, you can actually plug in and get a number. You can type that into your calculator and get a number. The number it gives you is going to be the ratio of the opposite to the adjacent sides. So in this one, it's about 0.363. Let's do 0.364. Generally recommend doing 3 decimal points if you're writing down your trig functions. Okay, one quick note. This is not tangent times 20. Okay, that's not what it means. All right, this is one whole thing. I am taking the tangent of 20. Okay, this is all together. You can't divide both sides by tangent to get rid of it. You can't divide 20. This is one piece and you cannot separate it yet. I'm gonna show you how to do that in another video. You look for my inverse video. I'll show you how to get rid of this. But you cannot separate these. This isn't multiplication or anything else. This is tangent of 20. It's one whole thing all together. It isn't t times a times n or anything else. Does that make sense? Okay, you are not looking at some kind of old thing. This is a brand new kind of operation that you've never used before. It's not something that you can multiply. All right. That said, it does give you a number. Right? It gives you 0.364, which then gives you something you can solve. 0.364 equals x over 10. What's the opposite of division? Multiplication. So you want to multiply both sides by 10. That will cancel the 10 out there into a big one. And multiply by 10 over here. And you end up with 3.64 as your answer. And that's equal to x. So I was able to find the angle or the side lengths. So I was able to find the side lengths, and all I needed was one side and an angle. Historically, you've needed 2 sides and do the Pythagorean theorem, but now with the tangent function, you only need one angle and one side. And you can find anything about that triangle you want. Okay, so that's pretty cool. Let's do another example, and hopefully that will clear things up for you. So here is your next triangle. I'll put the angle in the top corner here, but we're going to do the same process. Remember, the tangent function, it takes an angle and it gives you side lengths, the opposite over the adjacent. Okay, so the opposite, or the angle in my case is 50. So I'm going to put 50 in here. The opposite side is a little harder to see because I've rearranged this triangle a little bit for you, but you can draw an arrow from it and see that the opposite side in this case is 8. So I'm going to write 8 in here for opposite. And the adjacent side is the one next to the angle. It's not the hypotenuse, so that's got to be x in this one. All right, so we've got an equation. Remember, the tangent gives you the opposite over the adjacent. It gives you a number. You don't know what that special triangle is, but the tangent function does. So you go ahead and type tangent of 50 into your calculator, and you can go ahead and write this down. So it's going to give you 1.192 if you round to the nearest thousandth. And now we just got to solve for x. Some of you might be a little intimidated by this, but remember, you're just going to do the opposite operation. Always think when you're solving for x, you're always going to do the opposite. And right now, x is being divided. So the opposite of dividing by x is multiplying by x. Just like we did before, we're going to multiply, and it's going to cancel out into a big 1. And we've got to multiply by x over here as well, because we have to follow the golden rule. So that leaves me with 1.192x equals 8. And now I can divide both sides by that number. Something times x, I just have to divide by 1.192 on both sides. And that you can type into your calculator and get an answer. And I'll go ahead and show that on the screen right now. Okay, so your side length is going to be about 6.71. So that's tangent. Tangent, again, takes an angle and turns it into side length, so you can use that number in order to solve for missing side lengths. You don't need to use the Pythagorean theorem. You don't need to do anything else. You'll be in really good shape for this. So, and with that, I'm going to end this video. I'm going to do another video about sine and cosine, the other two buttons in there that we talked about